Hello. Okay. The goal of my talk really is to persuade you all that Hadoop isn't a scary thing and that everyone should use it. So I don't know how successful I'm going to be, but I'm going to try. Just a quick question, who here has ever used Hadoop before? Okay, so like 3 hands, so I have a lot of people to persuade. Okay. So I'm going to kind of go through the stack. I'm basically going to try and lay out what you can use Hadoop for and why it's useful and why it's the best tool to do the certain things that you can use it for. So I'm going to go through an overview of Hadoop, like what it is, what it does, and then I'm going to talk about the things you can do with Hadoop, so like why to use it, basically. Then I'll talk about why it's a great model to use it for those things, and I'll kind of wrap up with like some cool additions, and then have any questions that people might have. Okay. So this is my summary, so if you guys want to like go and hit the cowbell, you can just look at this slide and then leave. Basically, with Hadoop, you can like generate awesome production data sets, use it to like optimize different algorithms you may use, like search algorithms, and you can use it for analytics. And it's good at all those things because it's a batch processing system. You can access tremendous amounts of data like without taking down your database. It has all the retry logic associated with it, and it assumes the machines you're using are failure prone, and it can retry and do all sorts of clever stuff to make sure your jobs don't fail. And really, the big point is that you can use massive data sets and generate a lot of data, and it's really useful. So I want to give you a bit of context on Foursquare, because I'm going to use examples from our stack to like illustrate my points. So if you guys don't know Foursquare, we're the app where you check into a location, and then we can give you like specials and badges, and you can be the mayor of wherever you are. The other feature we have is called Explore, where we offer like socially driven like recommendations. So it's like a search engine, and we optimize it like a search engine. So that's where the optimization point comes in. But there's a lot of good things in our platform that require like a Hadoop data processing pipeline. Oh, yeah, and in case you didn't see those numbers, we have like a lot of data. So we have like 20 million users, over 2.5 billion check-ins, and we generate like 300 million like event logs a day, which is like 500 gigabytes. So Hadoop overview. So what is Hadoop? So Hadoop is 2 things. It's a MapReduce framework, and it's a distributed file system. And these things like scared me to death when I like started working at Foursquare, because they were like, hey, good job, you're the Hadoop guy now. And like I thought it was going to be really scary, but actually it's pretty simple, and I can hopefully do a good job of showing that to you. It is not an analytics platform, so most people like to throw around, like we already heard about data scientists, right? So they like to throw around the word data scientist, big data, analytics, big data analytics, like all this big data statistics, whatever. Hadoop isn't really designed for that. You can use it for that, but it's really more powerful in the way that I use it and the way that you can use it, and that's as like a production component of your infrastructure. And versioning is a pain in the ass. So there's a version 1 of Hadoop. Don't use it. It's a big pile of shit. Basically, use version 0.20 and then 0.2 maybe, or maybe 201. It depends. You're basically just better using somebody else's distribution, and they fixed all the bugs that are inherent in all the versioning. Okay, so scary slides first. So this is the kind of infrastructure of Hadoop in terms of how you lay out your machines. There is a master. So blue is MapReduce. Orange is a distributed file system. There's a master node. You talk to that node. It delegates tasks to its children. So the job tracker, you give it MapReduce jobs. It sends the task trackers, maps, and reduces to perform. The data node, you tell it to store this file, and it will send blocks of that file to the data nodes, which are orange, and they are redundant. So you can say how many of these data nodes you want holding a particular piece of data. Default, I think, is 2 or 3. It really depends on how confident you are that your machines aren't going to die. So it's also important, before I move on to the clever stuff, if you co-locate task trackers and data nodes, you get benefits because the data's in the same place. So clever stuff it does. So it assumes your machines are bad. So if a map task fails, for example, it'll get retried on 3 other task trackers. Your data nodes are redundant, so a piece of data is in 2 places, or maybe 3, or 4, or 5, or however many you want to specify. You can have many users, so there's like scheduling. You can tell users they can only store 100 gigabytes, or they can store whatever they want, or they don't get all the resources, etc. And you can use S3 like it's HDFS instead, which is really nice. So map and reduce. So the bulk of everything I do is writing map and reduce functions. This is kind of Ruby pseudocode for map and reduce. So these are like the Java APIs that I'm like fake programming against with Ruby. You basically, a map, you get a key and a value, and you output a key and a value, and whatever you do in the middle is up to you. So you can take, in this example, I take a line number and a check-in, and I output a user ID and a check-in. And the reduce function gets a key, and then a list of all the values you've output with that key. So in this example, I get a user ID and a list of check-ins, and all I do is iterate over the check-ins and count them, and then output that at the end. So the result of this job is a list of user IDs with a bunch of check-ins to see how many times each one is checked in. So it's pretty simple, but like when you have billions of records, this is pretty good. It's like one of the only ways to do it without taking down a database. So this is the other scary diagram, and this is the MapReduce pipeline. So in blue is what we just wrote, map and reduce, and all the stuff in the middle, basically what that does is organize the values and the keys so that the same keys are together, and then gives them all to the reduce at the same go. And you can override that stuff, but generally speaking, you won't really need to touch it unless you're doing clever data joins or something really intelligent. But generally, map and reduce, everything's good. The stuff in the middle just organizes it so that the reduce interface works. So before I jump into some examples of like why it's good, this is our pipeline at Hadoop, right? So at Hadoop at Foursquare. So we have like two types of data. We have log data and we have database data. Every night we take a fresh snapshot of all our databases and put them in S3. And every day we collect all the logs we generated through that day and put them in S3. That gives us a really consistent view of what Foursquare looks like every day for us to run jobs over. Event logs are probably 500 gigs a day uncompressed. And Mongo's are less than that, but that's all of Mongo. So we dump that every day, so it's probably a few hundred gigs. Okay, so obviously everyone here is Rubyist, right? So we use Scala at Foursquare, but for a long time we used Ruby, because I used to use Ruby and I didn't see any reason to stop. And to do that with Hadoop, you don't have to use JRuby or anything crazy. They have this streaming jar, so you can just basically give it two scripts, a mapper and a reducer, and it just pipes the data to them. So you read from standard in, you write to standard out, and that's pretty much it. Like if you want to define keys and values, you just put a tab in between them. And so the one before the tab is the key, the one after the tab is the value. And if you want to implement partitioners and sorters, you can do that with Ruby as well, or with just regular shell tools. So here's like a quick example. So like this is a mapper at the top. I read from standard in, I read each line, I split it into key and value, then I do some computation and output the new key and value. And I run that with like this pretty simple command line where I tell it to use a streaming jar and I give it the inputs, the outputs, and the mappers and the reducers. So obviously, like you want to test it, you want to do all those things. There's a bunch of Ruby frameworks. A framework called Wukong is really awesome. We used to use it a lot at Foursquare. It basically gives you like nice interfaces for your mappers and reducers, and makes it so you can test them and so you can call them without using Hadoop. So you can do the same code, use the same code like elsewhere in your stack, basically. It's really nice. The MR toolkit's going to be good too, but never tried it, so I can't really comment. Okay. So that was kind of the boring bit with the diagrams. It's going to be really confusing, so hopefully nobody's confused. I want to talk about things we can do with Hadoop. And I'll largely just rely on examples for this, right? So I'm going to talk about the generally best things to use Hadoop for, and then I'm going to give you some like concrete examples from Foursquare, and like, I think you'll see why it makes sense, right? Like this is really the core of it. If it makes sense to you why we're using Hadoop for these things, then hopefully you'll go away and like maybe play around with it after the conference. Okay, so generally, so these are the three things I'm going to talk about. So generating data sets, optimization, and ad-hoc querying. So generally with generating data sets, they follow this pattern, right? You want to do the same thing for a whole load of records, and then the output is going to be like a key and a value. So a good example is the user counting that we did, right? User check-ins counting. We do the same thing for every user. We want to count check-ins for every single person. And the output is a key and a value, the user ID, and the count of check-ins. So the examples I have, so this is like who has done what. So this is a snapshot from Foursquare.com. And we recommend you a place if more of your friends have been there. So in this example, like a bunch of my friends have been to Blue Bottle Coffee, and we have these counts at the bottom, and that's like Hadoop generated, right? Because we basically want to count every user venue combination. So that's 20 million users times like an average of like 1,000 places people have been. So that's a lot of records. So imagine doing that in like a queue, it would totally destroy your stack or your database. So you'd have to add throttling, all sorts of crazy stuff. If you do it in Hadoop, like it's a very simple job. You're just doing a count, right? And then you can put it back in a key value store for use later. So an example that doesn't involve counting, because most things in Hadoop involve counting, is generating newsletters. So we want to pull together everything your friends have done over the last week and generate an email that tells you about that and gives you kind of interesting things. So you not only need all your friends, everything your friends have done, everything your friends have liked, you also need what have they been looking at? Like, what did they really enjoy doing? What about their friends? Did people comment on their check-ins? Did people comment on their tips? And you can pull that all together and analyze that in the Hadoop pipeline and put it back in a key value store for use. Third example, suggested friends. So I'm going to do a counter example of this. So we basically take friends of friends and then see how many of them your friends have in common with them, right? So you can see I have 8